Hello, good morning. Today is the start of the 7th week of this course. This is the course on advanced composites, and last week we did a couple of examples related to solutions for governing differential equations related to laminated composite plates, and specifically we had solved for two cases, or actually three cases: case A, case B, case C, for a semi-infinite plate. In case A and case B, the plate was having a symmetric lamination sequence, and in case C and case D, the plate is having a lamination sequence which is not necessarily symmetric. And we had also developed the solution for case C, and today we will continue that discussion and we will complete the discussion on all the four cases. So, we will also, as a part of that exercise, develop the solution for case D. So, just to very quickly recap, case C was case C. In this we had a beam pinned and fixed at one end, and pinned and sitting on roller bearings at the other end, and then of course, there is a uniformly distributed load on the plate, and this plate is semi-infinite in nature, and the constant load intensity was Q, which is a constant. Okay. And the lamination sequence we said is 0 to 92. So, and then in case D, for which the solution still remains to be developed, the boundary conditions, the only thing different about this is that the boundary conditions are different. So, it is like this. So, the boundary conditions at this edge are u minus is equal to v minus is equal to w minus is equal to mx minus equals 0, and here, because the plate is free to move, nx plus is equal to nx y plus, and then of course, w is 0. Excuse me. So, this is w plus is 0 is equal to mx plus is equal to 0. And in the other case, case D, it is still loaded by Q, so, but the boundary conditions are that u is equal to v is equal to w is equal to mx is equal to 0 at both ends. That is the difference in boundary conditions. So, the solution for case C, we will just recap. The solution for case C by solving the differential equations, it was u naught of x equals b11 q naught a cube, and a is the length of the plate. This is the length of the plate is a, and just to recap, the coordinate system is located at the center. So, x is 0 at the midpoint of the length of the plate. So, with that understanding, u naught x we had calculated was b11 q naught a cube by 24 script a11 times d11 times 4 x by a cube minus 3 x over a plus 1, okay. And V naught x, we calculated that it is 0, and W naught x, it comes out to be QA4 divided by 384 script D11 16x over a to the 4 minus 24 x over a to the power of 2 plus 5. And these script A11 and D11, what are these? So, this A11 is defined as A11 square minus, oh I am sorry, it is not square, A11 minus B11 square over D11, and script D11 is defined as D11 minus B11 square over A11. So, this is the solution for case C, and then the other things we had also calculated was that for case C we found that Nx is equal to 0, Nxy is equal to 0, and Mx is equal to minus Qx square over 2 plus Qa square over 8. So, that is the moment resultant. So, now we proceed to case D. Case D, and we had developed some general solutions in the last class. So, the general solution for case C and D we had developed, it was A11 script times u of x equals B11 over D11 times Qx cube over 6 minus B11 over 2, no, I am sorry, over A11 times C3x square over 2 plus C1 minus B11 over A11 times C4 times x plus C5 minus B11 over A11 times C7, okay. And D11 times W naught x equals Qx4 over 24 minus C3 x cube over 6 plus B11 over A11 times C1 minus C4 times x square over 2 plus B11 over A11 C5 minus C7 times x plus C8. So, that is the expression for W. This is the general solution. So, this solution is good for both case C and case D. The difference will be the values of these constants, integration constants C1 through C8, and V naught x is equal to 1 over A66 C2x plus C6, okay. So, now we apply the boundary conditions for case D. So, we go back and look at what the boundary conditions are. For case D, u midplane displacements u, v and w and mx are 0 at both the ends, okay. They are 0 at both the ends. So, we apply these. So, these are 8 boundary conditions, 4 boundary conditions on one end, 4 boundary conditions on the other end. So, we use these 8 boundary conditions to find out these 8 integration constants. So, these are the three equations. So, now we find these integration constants C1 to C8 by applying these 8 boundary conditions for case D. So, the first thing we do is we know that, so we apply BCs. So, we know that V naught x is equal to 0 at x is equal to plus minus a over 2. So, if we use this, we find that C2 equals C6 equals 0, and that gives us, I am sorry, so this should not be subscript. ये subscript होता है, superscript होता है, this mid plane. अच्छा, anyway, so this V naught x is equal to 0. So, this is the first thing. So, what we have done is, let us list down these 8 boundary conditions here. U minus, V minus, W minus, Mx minus, so all of them are 0. And then on the positive edge, U plus, V plus, W plus and Mx plus, all of them are 0. So, what we have implemented are 2 boundary conditions, these 2 have been implemented. So, now we have to apply 6 other boundary conditions. So, the other thing is that M x, which is a function of x, is equal to 0 at x is equal to plus minus a over 2. So, which means this expression. So, mx we know that we had calculated as, so we will write 3 more expressions. So, sorry for this less organization. We had also done in the general solution, nx is equal to C1, nxy is equal to C2 and mx we had calculated is equal to minus qx square over 2 plus C3x plus C4. So, in this we will apply the second boundary condition, this boundary condition mx is equal to 0 at positive edge and negative edge. So, which means that minus qx square over 2 plus C3x plus C4 is equal to 0 at what? X is equal to plus minus a over 2. Okay. So, if we implement these boundary conditions, what we find is that C3 is equal to 0 and C4 is equal to q a square over 8. So, anyway, so this is one solution for V, and for the relation for M works out to be mx is equal to q a square over 8 minus q x square over 2. So, this is the relation for mx. Okay. So, now with this we have implemented 4 boundary conditions, 2 on V and 2 on mx. We have implemented 4 boundary conditions. The next thing we do is we implement the conditions on u. So, we know that u is equal to 0 at x is equal to plus minus a over 2. So, this should be superscript. So, if that is the case, the expression for u is this long thing, and if x is equal to 0 at plus minus a by 2, what we will find is that this term will be 0, okay. And also we have found that C3 is 0. So, this term also goes away. C3 is 0 because we found that by implementing the condition on mx, and when we implement the condition on u is equal to 0 at x is equal to plus minus 2, this term C1 minus B11 over A11 times C4, this becomes 0, because what that means is that this term, so not this one, this term will be 0. So, if we implement these conditions and do the math, essentially what I will do is I will directly write the relations. So, what it means is that C5 minus B11 over A11 times C7 is equal to 0, okay. And that can happen, and the other thing which comes out is that C5 is equal to C7 is equal to 0. So, this is what you get, and then when we implement the conditions on W, which is W naught is equal to 0 at x is equal to plus minus a over 2, we can calculate the value of C8 and C6. So, C6 comes out to be B11 Q A square by 12 D11, and C8 it works out to be 5 over 384 minus B11 over 96 A11 D11, okay. So, with these, once we put these constants back into the equation, the general solution for case C and D, which is this is the general solution for case C and D. So, we put all these constants back into the thing. What we end up getting are the following relations: u naught x is equal to B11 Q A cube 24 by subscript A11 D11 into 4 over x over A square minus 1 times x over A. The relation for V naught x is 0, and the expression for W naught x is Q naught A4 over 384 script D11 times 16x over A 4 plus 48 times P11 by 3A11 D11 minus half times x over A whole thing square plus 5 minus 4 B11 square divided by A11 D11. Okay. So, these are the solutions for case D. Now, when we look at this solution and we compare it with the solution for case C. So, this is the solution for case C. We find that the expressions for u naught x and w naught x are totally different. This is remarkably different than when we compared the solutions for case A and B, and when we were comparing the solutions for case A and B, even though the boundary conditions were different, the solution came out to be the same, exactly same, and that we ascribe to the fact that in case A and B, the out of plane problem and the in plane problem were decoupled. But in this case, the solution for u depends on w, solution for w depends on u, and so on and so forth. And for this reason, case C and case D have significantly different solutions. So, this is one important thing which we can take away from this thing, that in situations where the problem is decoupled, out of plane and in plane problem are deep coupled, if the out of plane problems boundary conditions are same, then the solution will be same. But in this case, the out of plane problem and the in plane problem, they are coupled, and because of this coupling, the solutions for u, v and w for case C are significantly different than that for case D. So, this is what I wanted to talk about today. We will continue this discussion tomorrow also, and we will look at the nature of some of these deflections and see how they vary along the length of the plate, and on what parameters do those deflections depend. So, that is all what I wanted to cover for today, and we will meet once again tomorrow. Thank you very much. Bye.